Hi, everybody. Thank you so much for joining us here for what we're hoping will be more of a regular thing of Varjo research chats, webinars. And my name is Geoff Bund. I'm the head of business development for Varjo Technologies here in the US. And I have the distinct pleasure of having with me today some very early adopters of our XR1 mixed reality headset, presenting some of their research and the projects that they've been doing the past year with our headset. With me, I have Cory, a PhD student at Virginia Tech, Doug Bowman, the director of the Center for Human-Computer Interaction at Virginia Tech, and Weilin Zhang, a plastic surgery resident at Virginia Tech Carilion Clinic. Now, just to set a little bit of context, Weilin, I'd love to ask you, well, I guess I'll set the stage a bit. This group did a really interesting feasibility study of surgical loupes using mixed reality. And what I'd love to direct to you, Weilin, is could you tell us a little bit about surgical loupes? Like what are they for those of people attending who might not know?
Sure, thank you. Good afternoon, everybody. Again, my name is Dr. Weilin Zhang at Carilion Clinic, Virginia Tech Carilion Clinic. To kind of start things off, surgery is a pretty large field that has, that we're working on many different kinds of tissues and different areas of the body. And so sometimes when we're operating and performing procedures on smaller areas that require magnification, we'll use a set of optical loupes, which are essentially these glasses that we wear and are custom fitted to the surgeon. Oftentimes we'll be given a pair during our residency training at a set fixed magnification. So as you can see in this picture, you have the frame, and then as well as a pair of lenses mounted on the frame on the glass part that can help with magnifying the image. So these are very important to use, especially in my field of plastic surgery, where we're working on very, very small details and using fine dexterity. So typically the standard size or the lowest size that we'll usually go with is like a 2 to 2.5 times zoom or a magnification, and they go up from there. So a standard pair might be 3.5 or 4.5 and so on. And depending on the procedure will kind of depend on what we need to use, what magnification we need to use for that situation. So certain areas like, closing a delicate part of the skin in the face might just require 2.5x zoom. If we're working to reconnect blood vessels that are in the hand, or doing reconstructive surgery where we're taking tissue from one part of the body to another and reconnecting vessels, that might require a higher magnification. And as well as doing cleft palate and working in the mouth may require some magnification as well, while working with delicate tissue. So the loupe is great. I mean, it's something that we typically use almost in every single procedure. However, there are some major disadvantages and limitations to using these. One I've mentioned before, that it has a fixed magnification, and it's once you wear one set, you have to essentially take it off and then put on another one if you want to change the magnification. And this can't really be done by yourself because, when you're in the OR, you're sterile, you can't, I have gloves on, I can't touch my face, which is an unsterile region. And they're also custom fitted. So each time I want a different set of loupes, I need to get them custom fitted for my exact interpupillary distance, and how far I want my depth of focus to be. So these numbers are all fixed, and they're not really customizable or variable for that matter. I'm looking through these small barrels. It's essentially tunnel vision. I'm stuck looking at a very limited area that also has a limited depth as well. So I think with these limitations, I came forward and spoke with Virginia Tech, with Doug Bowman and Cory to find out different ways of solving these limitations.
Yeah, thank you. And Doug, can you tell me a little bit about that? How is it that your department became involved here?
Right. Thanks, Geoff, and hi, everybody. So, yeah, Waylon, as he said, kind of emailed me or called me out of the blue one day, which was great. I'm always interested in talking to folks who have new ideas for applying XR technologies, because that's what we do in my lab. But so we felt like we could really help in this use case, because we have this center at Virginia Tech, the Center for HCI, which is a very broad interdisciplinary group. There's about 50 faculty members from all over the university. So not only in computer science, which is where I sit, but in human factors and industrial design and visual arts and psychology and many, many other fields. So one of the major theme areas within the center is what we call immersive experiences. And by that, we just mean VR, AR, and related immersive technologies. But we're focused on kind of the human side of those technologies, how to design for an effective user experience in various use cases. And so when Waylon came to us, this is the first time I was learning about many of the topics that he's expert in surgery, specifically plastic surgery and microsurgery, and what loupes are and all the stuff that he just told us. And we pretty quickly kind of came to, well, we think we might be able to help by using XR technology to do something that's more flexible than what you have right now.
Yeah, thanks for that. And Cory, I'd love to hear from you. Like, how did you start becoming involved in this, and like, what was your idea about using gaze interface? And can you talk a little bit about that and how you began designing this?
Yeah, so I'm a second year here at Virginia Tech, PhD student in computer science, interested in like researching augmented reality and its intersection with machine learning. So when I first got here, I immediately was drawn to Doug's work, and I was itching to get started on something. So this was kind of like opportunity meets timing sort of deal. And Doug and I, we talked about the virtual loose project, and we kind of like hashed things around to try and figure out like how would this even like work at all, because this idea is very new. So we kind of talked about well, what would make sense with virtual loops.
Yeah.
We was trying to figure out essentially how would we build our own device? Would we create like an integrated solution, or if we could more or less, or we would simulate this in AR simulate this in VR using augmented reality. And after thinking about those things, it kind of made sense to essentially one, go with an integrated solution, because granted I have a computer engineering background, but building an entire new hardware platform would have been difficult, and that's kind of where Varjo came into play. So and that's kind of like how we ended up well, that's kind of how I ended up getting into the project. But yeah.
So I have to ask you, so could you tell us why Varjo? Like, what were the things that we were able to provide that suited itself to this specific feasibility study?
Right. So with virtual loops, the point is to be able to zoom in. Video see-through AR essentially makes you see the world through the cameras in the headset. And if you think about video see-through technologies that are available now, not really too many not too many headsets have like the resolution that the Varjo XR1 has. To be quite honest, the XR1 far surpassed anything that was available when we first started thinking about this. So it kind of made the choice a no-brainer. And given that it was visual see-through, that means we had control over what the person was seeing, because the camera image comes in through the cameras, the combining happens, and then we display it to the users. So we kind of insert ourselves in the middle of that. So kind of using the gaze-based techniques that we'll get into a bit later, we allow people to essentially look at things and change the zoom level accordingly.
Yeah, so let's talk about that. Let's get into the details a little bit. I'd love to know how you started designing this. So we're looking at eye tracking, and then we're looking at eye tracking specifically to enable different kinds of zoom within a headset. Can you tell me a little bit about that? Like, I'd love to know, like, what were the things you had to consider? Like, I know you've been talking a little bit to me on the side about like dwell time and how you started shaping the zoom framework between what you call discrete and I think it's dynamic. I'd love to hear a little bit more about that.
So first with the virtual loose platform, we had to figure out, one, which interaction modality would we even use.
Yeah.
And we considered a few. Granted, we ended up with gaze, but we also considered speech. Talking, like if you've seen CSI, typically when they want to like zoom in or get more detail, they just yell enhance and it just zooms in, which is cool in theory, but it doesn't really make sense in the context of surgery. If surgeons are yelling enhance while they're doing surgery, you run the liability of one person essentially triggering multiple headsets, which we don't want. Then on top of that, surgeons need to communicate with one another during procedures as well. So speech didn't really make sense. Gestures are something that is very typical with a lot of these types of headsets, but it also doesn't make sense because surgeons are, one, they want to get done quickly. People's lives are on the line, so you don't want to interrupt the flow of surgery. So instead of like putting down your scalpel and waving your hands around and all of that cool stuff, we kind of decided to go in a different direction. This is kind of where we got into the idea with gaze. If you're able to control this interface just by looking at particular things, that one, it doesn't interflow the flow of surgery. Two, it also affords the user and on top of that, it's intuitive. It's fairly easy. Cassie, you could actually go back to that slide. I'm glad you brought that up, because this is something that I also kind of wanted to get into. So there's two different methods of magnification. We have our continuous zoom mode and our discrete zoom mode. Discrete is very akin to what you would expect with any menu-based system. There's a magnifying glass. You look at that for a couple of seconds, and then it brings up a secondary menu. The secondary menu has 4 discrete options. That's kind of where discrete came from. So you can choose between 1x, 2x, 3x, 4x, yada yada yada. But continuous is a bit more interesting, and be quite honest, it's my favorite mode. The way we kind of came about this idea is just like, if you think about like when you were a kid and you were pretending, if you ever pretended to be a pirate, you kind of look through your looking glass, shut your eye, and just for you, it might feel like you zoomed in. So that's kind of like where the idea came from. So you close your right eye and the interface zooms in. And conversely, if you close your left eye, you zoom out. And I actually have video of that. So I'll let this brief so you guys can see it for yourselves.
Yeah, just so everybody knows, what we're looking at here is the discrete zoom modality that Cory designed with the XR1.
So as you look, the icon will glow a bit, and then eventually the secondary menu will show up.
Yeah, and I think I might just do a shameless plug here that with the XR1 you can still read the text, even at magnification levels. Yeah, and I'd love to show, if it's okay with you, Cory, the continuous zoom video as well. Yeah, I love this too because the eye tracking's inset, so you can see the work that the headset's doing to basically connect the gaze and the video that Cory connected in his application.
Yeah, and those are the two different types of interfaces. The discrete makes use of dwell time, and dwell time is in the AR literature is essentially like a mode of selection. If you look at something long enough, it probably means you're interested in it. So I guess you set a threshold. So essentially, you set a threshold. If you look at it for X amount of time, let's activate this thing that this particular person is looking at.
Yeah. Well, that's great. So now I think we've covered a lot about like the problem set, what you all built here, and I'd like to talk a little bit about the experiment now. And like Waylon, can you tell us a little bit about like why suturing? Why would this be the first thing to look at when it comes to using mixed reality towards virtual loops?
Sure, thank you. Yeah, so suturing is actually one of the first things we learn as a medical student. You know, as you're going in through your medical training and kind of learning about the human body and whatnot. Part of what, as we're rotating through more procedural specialties like surgery and down in the emergency department, you kind of learn how to do some basic suturing of the skin. And so with that, you know, I kind of continued that kind of thinking where, you know, if you can get the basics down, you can definitely work and do the more advanced stuff. And so part of the initial thinking was, what can we do that's relatively simple, that can be simulated without actually working on an actual live human being or person. So the idea was to simulate suturing using relatively more delicate sutures or stitches. And so the finer it is, a little bit harder and more dexterity that you had to use to achieve a good result. And so the idea was to use the sutures to simulate closing of a skin under magnification.
Yeah, that's great. And so, Cory, can you tell me a little bit about how the actual experiment went? Like, what was the process, right? So you did how many people, and how did it go?
So we ended up the study ended with we ended up testing this on roughly 6 participants,
Mhm.
and I guess what were we looking for in the
Yeah, what
study?
did you have them do specifically while they were in the headset?
Right. So we had them essentially perform a suturing task that Waylon just described and you just saw a video of.
Mhm.
And we had 6 participants. So the first half of the participants made use of the discrete Zoom interface, and they, as you saw, they cut the fake piece of skin, and their goal was to essentially suture this back together. It's very akin to what surgeons would do normally during surgery, but we wanted to see how they perform while using the virtual loupes platform. So our primary research question was to understand the feasibility and the potential usefulness of
Yeah.
virtual loupes in microsurgery. Because it doesn't make sense to develop something if we don't solve the problems that are apparent with physical loupes, as Waylon had talked about previously. One of the interesting pieces was that not all of our participants except for one had no prior experience with VR, AR, or XR, anything like that.
Yeah.
So the results were pretty interesting to see.
Yeah, and so I know we at Varjo were really excited to learn about the overall reception of this. So, like, tell me about that. Like, what were the takeaways from this? Was it feasible?
Yeah, that's the probably like the big key takeaway from this is all of the participants except for one were able to complete the suturing task. Um, and but all of the participants saw the future potential of virtual loops. And this wouldn't have been possible without the Varjo XR one, because the low latency allowed them to essentially do the suturing task. Granted, there was a couple of downsides, like with the headset being a bit heavy, but those things, the downsides were mostly technical, and these are things that are being essentially hashed out with future iterations of the device, which I'm super excited about.
And if I could just jump in and add to that. So, one of the things you see here is that in our software implementation, because we were using an older version of a Unity plugin for the Varjo, we actually weren't able to provide color. So you saw those videos were black and white. We weren't able to provide color vision, and we weren't able to provide stereo. And so the fact that these participants in the study could actually perform the suturing task at all at a higher level of magnification is pretty impressive, because it's a very close task that requires very precise movements in depth. I mean, imagine trying to thread a needle, with one eye closed, right? It's really difficult to do. So it was really impressive, I think, that we were able to show that even in this kind of limited implementation, limited prototype, that the task was feasible to do.
Yeah, thanks for adding that, Doug. I was pleasantly surprised as well to see the resolution brought to bear. But I think one thing that I'd also like to touch on is that I almost smirked when I saw the first results of this, because the things that were specifically drawbacks here are things that we're addressing now in 2021 with the new generation of headsets. So I'd like to switch gears a little bit and start talking about what's next. So what are you all looking at working on now, this year? I know that in true to form, you all will be getting an XR3 pretty soon. And we're really excited about that. But can you talk a little bit about that, Cory? Like, will you come back and do this more?
Almost definitely. The first thing, so when we first started with this project, we decided that we do it in two phases. The first study, which we just talked about, is more or less to understand if the technology is capable, and the answer was yes. So the next part of the study, we want to do a direct comparison between physical loops and virtual loops once we've rebuilt the platform using the XR3, because as you've said, it addresses all of the limitations and issues that we saw in the beginning. We'll have stereo, we'll have color vision, the weight will be reduced, we'll have even better resolution, the eye tracking is better. So that kind of leads us to do, well, one, it allows us to see if the platform will perform better in the future, if surgeons will actually be able to perform better or on par with physical loops. In addition to that, we also want to infuse, right now, we say that this is AR, but the only thing we really do is zoom in and zoom out, which is nice to be able to do with gaze alone, but there's so much more cooler things that we can do with AR. One of those being this idea of whiteboarding that we've kind of like talked about a bit with Waylon. Waylon, could you add a little bit about whiteboarding and how it's done currently? And I guess we can kind of like go back and forth about like how we would do this in AR.
Yeah, sure. It's essentially exactly how it sounds. So typically what we have right now is a literal whiteboard in the operating room. And so if there's things that we need to record, so say for example, there are certain measurements that we need to get, we look at preoperatively, we'll look at some CT scans, some CAT scans that will kind of identify, where the blood vessel might be as we're dissecting down the skin and into the muscle. And we need to know these exact measurements so that we can watch out and kind of know where the red zone, where the caution zone is, of where to slow down, where to kind of look for these arteries, right? And so preoperatively, we'll record these spots. For example, artery A might be poking up out of the muscle next to the belly button around 2.5 centimeters on an x-axis, and then 1.6 on a y-axis. And we'll have a couple of these numbers, and we want to plot them out essentially. And having something like a whiteboard or some of a sort of method of recording this and easily being able to look back and forth is pretty handy to have, especially when you're in the operating room and you're in the middle of doing a procedure. So instead of kind of looking back and forth at an actual whiteboard, we can have an in-display whiteboard, so to speak, that will have some information that we can easily kind of offload and have in that spot.
Right. And I think the key part about that is this idea of offloading memory. I don't know about anyone else, but the only phone number I remember is my own, to be quite honest. If you would have asked me my brother's cell phone number, he's here. They said, but I couldn't tell you his number to save my life. So this idea of being able to essentially like offload that memory, and have it be in the scene to be something that you could refer to quickly, and something you could kind of easily bring up with using gaze again, would be super interesting. And then the second piece, this idea of unobtrusive adaptive virtual displays. So not only can we put these things in the scene, but we want to make sure that we put them in the scene such that they don't obscure very important pieces. Like if you're doing surgery, you don't want the whiteboard to show up directly on top of the patient, because you might nick an artery and people start bleeding, and that doesn't seem like it'd go too well. But those are the things that we're looking to do in the future with the XR3 and whatnot.
Yeah, that's great. Like, thanks so much for sharing that. In a little bit, we'll go to a Q&A. We're getting some really great questions from the audience, but I'd like to just do a bit of a recap and a bit of a shameless plug for all the new features that we'll have in XR3, so we can tell everybody what we can look forward to in 2021 with a new and improved study. And so I think what's great to have a takeaway is that here now in 2021, we'll have a device that gets rid of a lot of the bulk. We're about 50% lighter. And we have a better ergonomic design that's more comfortable for long periods of use. And then we'll also be enabling much more easily a lot of the other imaging things in the software stack that Cory ran into. So it'll be easier than ever to incorporate color, to incorporate stereo, and our eye tracker will remain as robust, and it even has a higher refresh rate. So there'll be some flexibility there. Yeah, and so for one, I can't wait to see what you guys come up with in 2021 and to revisit this later in the year. And yeah, I'd like to address some of the questions here from the audience if you all are interested. Doug, I'd love to hear what you think of this. Stephen has asked, what kind of industries could this be applied to other than the medical field? Like industrial or agricultural? Is there anything else that you all are looking at your center?
Yeah, absolutely. I mean, the possibilities are almost limitless in terms of application of these technologies. I mean, clearly it's been applied quite heavily already in the design field. So think of automotive design or interior design or architectural design. In all of these cases, you can kind of envision proposed changes and alternatives in situ, right there in the context where that design would be implemented. Certainly, there's lots of industrial applications that have been researched and fielded in things like logistics, warehouse picking, maintenance, comparison of plans with as-builts in like factories. The list goes on and on. But I'll slightly go off the question, actually. Many of the things that we're looking at in my group are not industrial applications at all. We're actually interested in kind of all-day mundane uses of augmented reality for the general public. So when we have AR glasses that are, the form factor of current eyeglasses, like Cory's stylish ones there, and they have all-day battery life, and they have super high resolution and field of view, and they include eye tracking and these sorts of things, it enables a whole slew of end user applications where we basically could replace smartphones with AR glasses, right? And I believe that's a pretty likely future. And so in my group, we're doing a lot of kind of experimenting and prototyping using today's technology for those future interfaces to kind of have some good design principles for them when the hardware actually does arrive.
Yeah, thanks, Doug. What a great answer. And I'd like to take this from Krista. Hey, Krista. Krista asked Cory, what kind of challenges did you have when using eye tracking as a selection method?
That is a very good question. So I think the basis of this is just like calibration. Eye tracking is very much a computer vision problem. You saw in the slides earlier that there were dots around the iris or pupil in my eye, and essentially, as my eye moves, the orientation of those dots and pupils, those dots change. So if your calibration is bad, then you end up with bad eye tracking. During the study, let's just say the first, Doug, don't pretend you don't hear this with Doug. But in the beginning, there was a situation where I kind of misunderstood like how the calibration should have been done. We had people calibrate the headset while facing forward. However, when surgeons do surgery, they're facing down with their head. So if you do the calibration while their head is up, but their head is down during surgery, the headset shifts, and that changes those dots that are on the eye, and it kind of makes the eye tracking kind of not work the way you would expect. And that was one of the primary challenges that we addressed, but it was a very easy fix. So instead of calibrating with their head in a neutral position, we just had them calibrate the headset when their head is down. But that solved that issue, and that was one of the that was like the primary challenge of eye tracking.
And if I could just add, I mean, I think there were some design challenges as well. So, once the eye tracking is working well, you still have to decide how you're going to use the eye tracking data to accomplish the user task. In our case, choosing a magnification level. So, Cory showed these two interfaces that we have, and one is basically a menu. But even there, there were questions of like, how long should the dwell time be, right? How long should you need to look at a menu item before it gets selected? We don't want it to be too short because you get too many false positives, but we don't want it to be too long because it gets annoying and breaks the flow of the surgery, like Cory was talking about. And so we actually defined or designed this two-phase menu that you saw, right? So you have to first dwell on the magnifying glass icon and then dwell on the magnification level that you want. And that seems like it's less efficient, but it's actually quite good in terms of keeping the interface as unobtrusive as possible. So we want the field of view to be completely clear of virtual objects when we don't need them. So the only thing that's on the screen most of the time is the magnifying glass. And a dwell on that then quickly brings up the menu, and we do a very quick dwell in the second level since we know that you want to select a new magnification. So there's all sorts of little design details like this that come up when you're using eye tracking for input.
Yeah, and I'm reminded of a thing I heard in a design class, that the best design is sort of invisible. And I think that it goes to show how well it's designed, that it was intuitive and just sort of seems simple, but there were actually a lot of choices behind it. I think it's just great. I I have a question from James. How is Varjo's XR auto IPD adjustment feature used in this study? And interrupt me, Cory, if I'm wrong, but I'd like to answer it in that it's one of the great things about our headset is that it automatically senses the IPD. So it can be handed off between research subjects with at least that variable kind of locked down. The headset itself will sense the IPD to within 0.5 millimeter and actuate to it, so that all the surgeons using it could be assured of the best possible image quality without painfully or miscalibrated images.
Right. No, you're spot on. And that was one of the things that it kind of spooked me a little bit when I first used it, because you put on the headset and you just hear, and it's like, what is going on? But it kind of is just adjusting everything to your eyes. But like you said, that means, so this is kind of like, if you want to talk about like business and whatnot, that means one headset could be used by multiple people, not in COVID, but it could be used by multiple people, because as you said, it adjusts the IPD, which is one of the problems with loupes. Loupes are custom fitted to one person and they come in one set level of magnification.
I would just say too that auto IPD is huge, coming from someone who has been using VR HMDs for 25 years. This is the first time I've seen that feature. And so what we typically had to do in studies was have an optometrist device to measure the participant's IPD. So it's a procedure, first of all, that my students are not trained for, and so they may get it slightly wrong. But you have to do that before the study, and then make sure you try to tell them how to adjust it so that it gets to the right IPD value and so on. And then you ask them, does it look right? And they're like, maybe, I don't know.
Yeah.
So having it done automatically is actually huge from a research perspective. That's a factor we don't have to worry about in our studies anymore.
Yeah, and I've also seen a question I could direct also to Cory, that what will it look like to implement color now into this in 2021 into the imaging pipeline?
So this is something that's super interesting, and I also saw like there was another question from Levon Wallace about just that. So given that this is a video see-through headset, and you can kind of insert yourself in the middle of the imaging pipeline, not only would you be able to potentially allow this to work for people that are colorblind, but it also affords you to augment it in other ways. You would be able to, let's say, increase the saturation of a particular region, which I think is super interesting. And I believe, Waylon, you had some ideas about how that'd be useful in surgery as well, right?
Yeah, I have some ideas. Without going too much into depth, I guess a little bit beyond the scope of this talk, but there's different kinds of cameras that we could utilize in the operating room that we utilize now already in fields like general surgery and abdominal surgery. They use things that can assess perfusion of certain kinds of tissue or blood flow in certain types of tissue. And they use special cameras for that to assess it and use essentially they inject some special dye into the blood vessel, and then they kind of assess the blood flow and see how well the tissue is perfused using a special camera that can pick up on that dye. So utilizing that and kind of putting it in like a modular system where we can kind of implement those different kinds of cameras would definitely be a really interesting kind of area to explore further on when we have like a more mature platform.
Yeah, thanks, Waylon. Thanks for that. I almost hesitate because this question might be a little bit complex, but Tim asks, how do you see mapping phantoms for medical training simulators? And I think what he means is maybe like going a little bit beyond whiteboarding in terms of the simulation and training for surgery, but I'd love to hear what you all think of this. Like, if there's application here.
Yeah, so the idea of mapping phantoms One, it would be a bit difficult because my assumption would be that you're essentially, if you've played any racing games and you race against the ghost that's better than you, you're kind of like trying to follow it. You'll follow like the race line of the ghost to get a good race line. And I would imagine that this would be something similar for surgery. It's just like, well, if I follow this phantom, then I'll be able to do this brain surgery, which is great as a concept, but is very difficult to do because it would require like one very precise tracking and registration. You would have to make sure that this sort of thing is like very accurate to the human body. And given that this is a very microsurgery, well, surgery in general is a very high stakes area. It would be something that I wouldn't necessarily steer away from. But it would be something that you'd have to take very care to make sure that it's very accurate, and that's more of a technology piece. You want to make sure the tracking is as accurate as possible. You want to make sure that the phantom is in the most correct, I guess, is in the best place, such that you don't run into weird issues where the arm is one place, but you're in another place.
I think he also asked about training. So for training, the stakes are lower for sure. And maybe, I'm not actually sure what he means by phantoms, but maybe he's also thinking of things like mannequins, which are used in medical training a lot these days. So it's, it's a physical form in the form of a human body that has, all the correct parts and has the right tactile feel and so on. But the combination of augmented reality with mannequins, I think, could be super interesting and a rich area for design, because these mannequins have to be super complicated in order to have like real fluids flowing through them and that sort of thing. But many things could be done through AR on top of kind of the base mannequin. So that's an area that would be interesting to explore.
It also kind of makes me think of the Magic School Bus.
I can answer a couple quick, more simple questions too. Hey, Cedric, the XR3 does not have Linux support, but we are actively, researching it and working on it. We don't have any type of formal communication about it, but it's something that we are looking at. And also to Mark, the IPD range of our headsets is 58 to 72 millimeters. So we have a pretty wide range, and we're also doing really well at addressing the overall narrower IPD ranges of the human population. So yeah, I'm excited about that. And I think we're probably coming up a little bit on time. I'd like to just mention one thing real quickly before we finish, which is that Varjo now has a formal academic program. Cassie, would you mind putting that slide up? Yeah, and we've seen so much great adoption, and we're so excited about projects like this that are going on, that we do have some, some exclusive things that are only for academic and research institutions. So if you want to know more about it, please get in touch with me. And then with that, I'd like to ask the panelists, do any of you have any concluding thoughts before we close the session?
I'll jump in. I'm super excited. So one of my dreams as an AR researcher and whatnot is to one day get AR to the point where you can play video games with your body as the controller, and you would need like a really good headset in order for that to work, and there needs to be good eye. So think about it in a multimodal sense. Instead of just using gaze, you use speech, you use gestures, you use everything to essentially like immerse yourself, like more not I don't want to immerse yourself, but to augment the world around you. Think about like how when Pokemon Go first came out and everyone was super excited, but you spent most of the time just looking at your phone. Imagine if you had like a cool Varjo headset that was wireless and you could go outside with your friends and pretend to throw Pokeballs at random Mewtwo's and Pikachus and all of this other stuff. That's the future that I'm excited about. Being able to play video games with your body as the controller, and how that kind of leverages multimodal interaction.
Yeah, absolutely.
And I mean, so my interests are so much more mundane than Cory's. I said that I wanted to like read my email in AR, and he says he wants to play video games in AR. But in all seriousness, I think something that is really exciting as we continue down this path is what Cory mentioned earlier, is the combination of AR with AI and ML. So you can go a long way with augmented reality and good user interface design. But if we can make those interfaces intelligent and adaptive to your needs in such a way that they're not annoying, but actually helpful, and you get the right information kind of where and when you need it, I think combining those technologies with these AR technologies is going to be really exciting.
Yeah, I agree. I couldn't agree more. And Waylon, thank you also so much for joining us.
Yeah, it's been a pleasure. This is definitely like a field that I'm interested in, never had any experience in. You know, I heard on the news about, you know, HoloLens and all the other cool little things that came out. And then this is kind of like a whole nother field that, you know, it's pretty fascinating. And I hope to kind of get into more of this side as well.
Yeah, absolutely. And, you know, yeah, thank you so much, everybody, for joining us, Doug, Cory, Waylon, and thanks everybody who logged in. I really appreciate your attendance and your active participation. And also, please stay up to date. We'll be doing some more of these as the year unfolds, and we'd love to include everybody in that communication as it develops. Thank you so much.